Okay, so we're going to try out these digital type notes. It's a really good idea for you to be taking notes while I'm going through these problems. Copy down an example or two just so you have them for future reference. If you've printed these notes, it's a really good idea to fill them in with the information that's on here, just as you would do in class. But the benefit is here, if you want to hear an explanation of something again, you're welcome to go back and just pause it and go back a few seconds and understand what I said there. So the first thing is we're going to shift away from this idea of surface area, which would be if you wanted to wrap a present, it would be how much wrapping paper you need around a box. So you would be able to calculate the surface area so you know how much wrapping paper you would need. But in this case, we're going to talk about volume. Volume is how much space that a figure occupies. So let's say we want to know how much room inside the box there is for the present or whatever you're going to put inside the box that you want to wrap. So that's the difference between the surface area and the volume. So the volume, we're going to be talking about this area inside here, or the space inside there. So the first thing is we have right prisms and we have oblique prisms. This oblique prism is more of like a slanted type shape. So in each of these, you can think about them as post-it notes. Each layer is the same size and there are the same number of sheets in each of these, because basically we just took this one and pushed it so that it was slanted over so it looks like this. So the volumes must be the same. This is Cavaliere's principle. So this is your height in the right prism here, and it makes a right angle here with the base. The same thing here we're going to need if we have an oblique prism. We need to make this our height. This one here, that's perpendicular to the base. There would be a right angle here. So we were going to need to draw that in. There's going to be a few questions that may ask you about oblique prisms. I need to make sure that the height is still perpendicular. That's something that we've been working with throughout the chapter and in previous chapters. So drawing that in with maybe a dotted line, you'll see an example a little bit later on in the notes. So the volume of a prism is going to be the product of the area of the base and the height of the prism. So we have this big B. There was some question about what is the B when we were talking about surface area, and the B, the capital B, is going to be the area of the base. So whatever your base is, you find the area of it and then multiply by the height to find the volume. So let's look at this example here. This prism here is a triangular prism. So we need to make sure we understand that we need to flip this up in order to think about this as this triangle and this triangle are the bases of this prism. It's important that we know that so that we are finding the area of this base and then multiplying it by 7, which is our height here. So in order to find the area of this base, we needed to use 30, 60, 90 triangles, the properties here. So across from the 30-degree angle, we have 4. And then across from the 60-degree angle, we would have 4 root 3. So that's what's written here. So in order to find the area of the base, we just do 1/2 base times height, and we get 8 times the square root of 3. So now we just multiply that by the height, and we have our volume of 56 root 3 meters cubed. So it's really important that we have meters cubed. So it's always cubed when we're talking about volume. Your unit is always going to be cubed. Just like when we were talking about area, your unit is always squared. So back to over here we have a rectangular prism. So in a rectangular prism, you have you could have this as the base and this as the base, this rectangle here and this rectangle here. In this case, you only could use the triangle here and this triangle here because these are the ones that are parallel and they're the same, they're congruent. So these two are congruent and they're parallel. Those two that are shaded, those rectangles, and then also you could use any of the other rectangles as the bases, but you just need to make sure you choose one and then stick with it throughout the problem. So we chose these ones here, the ones that are shaded, these rectangles. So those are going to be our bases. We need to find the area of this base, which is going to be 12 times 6. And then our height is going to be, if we were to stand this up and make this the bottom, this rectangle the bottom, then our height would be over here, 8. Our height is 8. So we multiply by 8, and we get that the volume is 576 centimeters cubed. Really important again that we keep it, we make sure we have centimeters cubed, feet cubed, whatever your units are cubed because it's volume. So we'll see that here. The next thing we can also talk about the volume of cylinders. So the volume of a cylinder is going to be the product of the area of the base and the height. So again, it's volume equals the area of the base times the height. In this case, our base is a circle. So we can substitute that into our equation if we want to think about it that way, and we have volume equals pi r squared times the height. So let's look at this example. We need to make sure that we know that it's the radius squared. So this is a diameter, 16 is our diameter, so our radius is going to be 8. So then we use volume equals the area of the base, which our base is a circle, so we have pi r squared times the height. So our radius is 8, we use that here for the radius. 8 squared, 64 times 20, we get 1,280 pi centimeters cubed. In this case, it didn't say to leave it in terms of pi or round to the nearest decimal point, or not round to the nearest tenth. It doesn't say to leave it in one form or the other, so you're welcome to choose. This is the best answer here because it's the most exact. When you're plugging pi into the calculator, you're always getting an approximation. So I would always keep it in the 1,280 pi centimeters cubed. This is the most exact answer. So let's look at a few more examples. And we're going to talk about one thing here called a composite space figure. So it's a combination of simple figures that we know how to find the volume of. So we have in this figure, we have a rectangular prism here on the bottom, and then we have half of a cylinder here on the top. So our first way of solving this is going to be, it's listed over here in this area, and we're going to use finding the volume of this prism, and then we're going to add the volume of this half cylinder. So let's first find the volume of the prism. We need to do the area of the base times the height. So we can have 6 times 9 times the height 8. So we have, that's going to be 432 centimeters cubed. So that's our area, or our volume here. Then we're going to find the volume of the cylinder. So we have pi r squared, because that's the area of the base, times the height. Now if this length is 6, then that means this whole length up here is 6. So half of it's going to be 3, that's our radius. So we find that radius squared gives us 9 times 9 is the height, because we want, if this is our base, then our height is going to be this length, is the same as the one down here, the length down there. So we get 81 pi. That's for the whole cylinder. So when we go to find the total volume of this composite space figure, we have the volume of the prism, which is 432, and then we're going to take half of the volume of the cylinder. So we found the volume of the cylinder was 81 pi. So now we're going to do 1/2 81 pi. Since this is in terms of pi and 432 is just a number, we're going to leave it like this. We're going to have 432 plus 81 over 2 pi, and this should be centimeters cubed. My picture of the notes here got cut off, but it's definitely centimeters cubed. Make sure that's written somewhere in your notes that you're taking. So another way that we really can think about this is this, if we flipped this up on its side, it's really important that we understand what our base is and what our height is going to be. So we can flip this figure up onto its side and make this whole thing, this whole base, this whole area here, the base. So we could find the area of this whole base and then multiply it by the height of 9. So you may choose, in this case, either way to do it, but it might be easier for you to be able to see that this is the base if I stand it up on its side, and then 9 would be the height. So to find the area of this base, we'll have the area of this rectangle, which is 6 times 8, plus the area of this circle. So, but only 1/2 of it because it's just a semicircle. So we have 1/2 pi times 3, because that's our radius again, squared. So we get 9/2 pi. And then 48 plus 9/2 pi is our area of the base. Then all we need to do is multiply it by the height, which is 9. And when we distribute this 9 to both terms in this addition in the parentheses, we get 432 plus 81/2 pi centimeters cubed. So using either method, we got the same exact answer. So you may choose either one that you want to do. It's up to you how you want to do that one. So then there's 2 more examples we'll go through. So in this case, we have what is an oblique cylinder. So it's tilted off to the side here. So we wanted to find the volume of the cylinder and round our answer to the nearest tenth. So that means we're going to use an approximation. We're going to put pi times whatever we get into the calculator, and it's going to be an approximate answer. So let's think about this. We need to have the volume equals the area of the base times the height. Our base for an oblique cylinder is going to be a circle. Just the way it's drawn, it still is a circle. It's still a cylinder, so it is a circle on the bottom. So we have pi r squared times h. It says that r is 8 centimeters. So we're going to square 8 centimeters squared times the height of 12. So when we multiply that out, we get 768 pi. And then when we plug it into the calculator, it's approximately 2,412.743. When we round that to the nearest tenth, this 4 is not going to change the 7, so we get 2,412.7 centimeters cubed. Always centimeters cubed or any units cubed. So this last example we're going to go through is we're going to find the volume of the prism, the nearest whole number. So keeping that in mind, we need to find the area of the base. That's our big B here, the area of the base. This is a pentagon, so we do need to remember from last chapter that to find the area of a polygon, we need to use 1/2 the apothem times the perimeter. So we are given this apothem here now. It's 3 inches. And the perimeter is going to be, if this side is 4, we have 5 sides, so we multiply it by 5, and we get 20. So our area of the base, based on 1/2 apothem times perimeter, is going to be 30 inches squared. Because this is an area of the base, so it should be 30 inches squared. Now, if we want to find the volume, we just need to have the area of the base, 30, times the height, which is 9. If we were to flip this over on its side, bringing this down to be on the flat surface, then we'd have 30 times 9, and that's 270 inches cubed. Again, we were rounding to the nearest whole number. In this case, we didn't need to worry about it. And that's about it for this. I hope you got some of your questions answered, and I hope you are able to rewind if you needed to get any more explanation. I'm excited to hear about your feedback, how you liked this type of style notes. I welcome any type of feedback you have. Just let me know. And again, we said in class we will be doing the notes additionally in class. I do want to know how many of you were able to watch this video. So I'm going to ask you to tomorrow, when we ask what your answer to the question is, I want you to give your answer to the question. I'm going to ask you, what is your favorite food? So when we ask you tomorrow, what's your answer to the question? Answer with your favorite food. Does that make sense? Hopefully, I can't get your feedback because you're not in front of you, but what is your favorite food? That's the question, so I hope you can give the answer tomorrow. Thanks for listening and watching. I hope this helped. Thanks.